to Transformation in Trials. Welcome to Transformation in Trials. This is a podcast exploring all things transformational in clinical trials. Nothing is off limits on the show, and we will have guests from the whole spectrum of the clinical trials community. And we're your hosts, Ivana and Sam. Welcome to another episode of Transformation in Trials. Today we have Professor Graham Dutfield with us. Hi, Graham.
Hello.
So, Graham is a professor of international governance at the University of Leeds, and he also wrote the book called The High Design of Purest Gold, A Critical History of the Pharmaceutical Industry from 1880 to 2020. And today we're going to be focusing on the evolution of IP regulation in pharma and how it could be transformed in the future. Now, as we start this topic, I would like to ask you the following question, Graham. Just to set the stage for us, can you start off by talking us through the purpose of patents and IP rights protection? And what is it that the state is trying to encourage and discourage with this tool?
Well, patents actually have a very long history going back to Venice in the 1470s. And then the next country to have a patent law was England in the 1620s. But patents really started off as trade monopolies, often basic things like salt and simple products. But patents were also given to explorers. There are permits for explorers to go and discover new worlds and claim ownership of land, treasure, resources, personally or typically on behalf of the crown. So Christoffer Columbus had a patent to take with him to America. Now, in time, patents became reoriented towards inventions. And that really starts off in England and then becomes, of course, globalized now. By the late 18th century, patents became understood by judges and others as a kind of bargain where the inventor discloses the invention. You might say a kind of recipe, the recipe for the invention. And in return for that disclosure, they get a period of exclusivity. In those days, it was 14 years. Now it tends to be 20 years. So governments think of patents nowadays as incentives to not just to disclose an invention, but incentives to actually exploit the invention, invest in the research and development that takes a disclosed invention actually to the market. Of course, that perspective isn't necessarily shared globally because some countries are, for historical reasons, and because they are poorer countries, tend to be a lot more skeptical about this kind of argument. And it's often explained by economists that the function of patents tends to vary a little bit by industry. Now, for pharmaceuticals, it's not just about patents. There's also trade secrets are really important in relation to manufacturing methods. And there are also rights relating to third-party access or use of clinical trials and other data, which came up at the World Trade Organization in 1995 with the so-called TRIPS agreement, which provides a whole range of intellectual property rights. Beyond that, it's also perhaps important to mention trademarks. Trademarks are extremely important for the pharmaceutical industry. Initially, trademarks were just on names and logos or figurative marks, but increasingly you see the industry is using so-called non-traditional trademarks, including coloring on packaging, sometimes colors of the pills, and also the shape of pills as well. And these play an important role in distinguishing in the vision of the patient, of the consumer, the customer, this particular product from other similar products on the market.
Well, maybe could you talk a little bit more about what is it that is the purpose of having patents? What is it that we're trying to get more of?
What we're trying to get more of is more inventing, of course, but we also try to get more investment in inventing because, of course, pharmaceuticals are expensive to discover and particularly to develop. Furthermore, there's considerable risk. And it's actually those industries which have the most research and development costs, where the investment is most risky, where the exclusivity of a patent is most important for those companies. And while one can be quite critical of patents in certain respects, some way or another, we have to create some kind of incentives, whether it's through law or regulation, whether it's just through monopoly or some other means. They're not going to do it if anybody can just enter the market as soon as a new product is found to be commercially successful.
And what kinds of, or what parts of pharmaceutical products can be patented? Or is it just the products? Is it the processes? And how has that changed over time?
For most of patent law history, patents have really been for products and to some extent for processes, for methods of making those products. But with the pharmaceutical industry, particularly, not just pharmaceuticals, but other industries too, but because the pharmaceutical industry is characterized by being high investment and risky, but also very, very complex. The patent system has evolved in certain ways so that patents can be granted also on new uses of old things. And patents can be granted also on human genes. And that's quite important in relation to predictive and diagnostic testing. Also, of course, in drug development, in addition to which patents are quite important in the area of molecular biomarkers. Well, what are biomarkers? Biomarkers are any kind of sign. If it's molecular, it's just microscopic, but a sign, it could be itself be a gene, it could be something else that is helpful, among other things, in customizing medicines and dosage for individual patients or certain classes or groups of patients. So the patent scene has got very interesting and very complicated, and that has, to a large extent, been driven by this particular industry. Now, since the sort of 1980s with the biotechnology, and the big difference in terms of products of the biotechnology revolution, as it's sometimes called, is that you have the so-called large molecule drugs. Typically, these are monoclonal antibodies, but there are other types of large molecule drugs too. And these really change things quite considerably. Now, some economists talk about discrete technologies and complex technologies. Now, what's the difference? Well, a discrete technology is one where there is essentially a single thing which might comprise of one or a few parts. And this means that a patent or a small number of patents is going to provide enough protection for that particular product. So that's been the case for small molecule drugs over a long period of time, over 100 years. Now, with these large molecule drugs, they're the complex technologies. I suppose it's a bit like comparing a very simple device, a paperclip, and a mobile phone. Now, I don't want to suggest a small molecule drug is as simple as a paperclip, but the point I'm making is not that. When I say discrete technology, I don't mean simple. I'm not saying it's simple. Right? But a new paperclip, how many patents would actually protect that? Probably one or maybe two. It's hard to think more than that. Now, with a mobile phone, here I'm holding an iPhone here, there are lots and lots of IP rights locked up in this product. And those IP rights are patents, they're also trademark, design right, there's also copyright, in addition to which there are different parts that are owned actually by different companies who then, so there's lots and lots of licensing as well. So lots of complex transactions and lots of separate rights, which have to be sort of aggregated in some ways to form the new product, the new mobile phone. So this means that companies have an incentive and the opportunity to have large numbers of patents in relation to these very large complex molecules. In addition to which, because the methods of manufacture are so incredibly complicated, that there'll be lots of patents on those, but some of the methods are likely to be kept back as trade secrets. So we're now seeing the industry changing in terms of its patent practice, because the sheer number of patents these corporations have now are really quite enormous. And it's not just patents, also, I mentioned trade secrets, there are also trademarks. There may even be also design rights. I know there's a design right on a few medicines, such as I know Viagra is protected in Europe by a design right, the actual pill itself, in addition to which there's trademarks too. So the whole IPC now is incredibly complicated, and that has been triggered really by this biotech revolution and the emergence of these new types of very large molecule drugs.
But that's very interesting. So in fact, the increased complexity of biotechnology has also resulted in increased complexity in, you can say, the complex of patents that you need to protect your technology.
Yes, that's right. And although we call it a revolution, the biotechnology revolution, in some ways one could also say it reflects the way the industry has used IP going back a long time. I say that because if you go back to the 19th century, companies like Bayer were very creative in using patents and trademarks actually both together. So using more than one type of IP right. They are very experienced in doing this. And it used to be really the German companies did this first, and then the US companies got wise to it as well. And I think that had much to do, if I might give a bit of history here, the late 19th century was a time of the so-called Second Industrial Revolution. So you have things like electronics, of course, aeroplanes were starting up too. So, cars, and you had fine chemistry, electronics, and new machinery for moving people, mostly on the ground, but also in the air. But beyond that, we also had research and development being done in-house. So instead of the old days where you had the odd eccentric scientist doing amazing things in their kitchens or in their garden sheds, these were employees in a lab, in a company lab. So you had in America, you had Thomas Edison, and in Germany, in Europe, you had Bayer, was a bit like that too. A chap called Karl Duisberg, who's head of research at Bayer. He's set up Bayer in a bit like how Edison set up his company in America, with large numbers of scientists and technologists all working together, working as teams. So you have really team inventing, collective inventing, with large numbers of people working together. So you had lots and lots of inventing, lots of patents, and it was very systematic. It wasn't random, somebody just having a lucky day, something happens and then, oh, look at what's happened here. It was almost, it was like a strategy. We need to do this, and very goal-oriented, which way it wasn't so much before at all. In fact, in some ways, in earlier times, it seems a bit like they were amateurs doing this. Now it's become much more professionalized, professional scientists. So that made things quite different, but it also enabled the massive increase in the number of patents. There are more and more things to patent. And as you have more patents, you think, well, how do we manage these patents? How do we manage these patents to actually generate more income? So when you have lots of patents, you either let them sit there and leave after them to one side and forget all about them, or you want to do something with them. And that doing something with them involves things like licensing, and then you operate more internationally. So you file patents in other countries, and so you develop a whole patent strategy, a strategy of patenting, which involves large numbers. So suddenly you have this massive increase from the 1880s onwards, and you get the same kind of thing happens in the pharmaceutical industry in the 1980s. 100 years later, again, you have this massive increase all over again. So there's a big sort of step upwards 100 years apart.
Oh, that's interesting. So we have a kind of industrialization of the patent law, also in the invention process in general. That's it. Invention, yeah.
It becomes collective and organized and systematic.
And in the beginning, a lot of the life sciences companies were actually based in Europe, and then there was a shift that focused more on the US side of things. Maybe can you tell us more about what happened there and how is the innovation geographically placed today?
Well, I think the modern pharmaceutical industry really, if you're looking for an origin, you'd probably say Germany. And I think that has much to do with the education system, the higher education system, where whereas in England we still had Oxford and Cambridge were very dominant, and it was very much the arts and humanities, not really science. And the Germans did much to turn science and engineering into areas of scholarship. So these first scientists were actually working at universities. And actually, there weren't many companies in those days in Germany where they could work. So a lot of them came to England and they joined English chemical firms, or they worked in universities, or they worked actually in brewing, in beer brewing, among other areas where you need good chemists in beer brewing. And when Germany was unified with Bismarck, went back to Germany. And some of them immediately worked in these companies, or they worked in university and became consultants to these drug firms. And so it's not really surprising that Germans suddenly became very dominant very, very quickly. And their ability in chemistry, in fine chemistry, was well ahead of everywhere else. So they became very quickly dominant up to the First World War. Now, of course, in New York and the eastern states of the United States, a lot of Germans went there. And some of these companies set up branches actually in the United States. So so America did catch up, but they caught up not just because because Germans moved there and they were quite impressed with the German system of education as well. But also because during the First World War, when America joined, they essentially expropriated all of the patents and trademarks owned by the German companies, as did the British too. We just took all the IP rights of Germany and auctioned them out or gave them away to domestic firms. So it was a massive technology transfer particularly to America, but also to Britain as well. So between the wars, the United States really does sort of catch up. The education system is really, really improves in a big way. And America starts to become dominant. Britain catches up as well. But Germany is still very strong. Even after the Second World War, Germany is still very strong. German companies, but of course now you can see the United States is very dominant. Of course.
Yeah. Yeah. Well, we've kind of looked at the evolution of patent law until now, some of the big trends that shaped it. I would like to shift gears a little bit and talk about, well, how is it today? Are we getting the kind of invention that we would like from the way that our patent system is set up now?
Look, I'll try and answer that question by talking about how industry sort of makes its money out of medicines, and then we'll go on to that question. So how does the industry make its money from medicines? Well, by discovering new drugs, right? Obviously, that seems like almost goes without saying that they try and discover and develop new medicines, especially ones that are very different from others that are much better. So superior medicines rather than just more of the same. Although often they do end up with just more of the same. That's not very exciting. But sometimes they do come up with amazing new first-in-class drug, which is fantastic. But it's really important to understand that this is hard to do. And the easier thing to do is to try and generate further income streams from existing or old drugs. So how to do this? Well, one way is by expanding the indications. And it's much cheaper and much easier and much less risky to add another indication to an existing drug than to develop a new drug for any indication. So sometimes they might identify, let's say, a subgroup of patients who respond well to a medicine, an old drug. I'll come back to that one in just a moment, because I wanted to point out here that a number of surveys that have been done in America and some European countries as well, and I think also Canada, have showed that a surprisingly small number of patients actually do benefit in a substantial way from any particular medicine. So for every one person who says, this is a great medicine, it's really helped me, there are maybe several people who say, look, it does nothing for me. And some people may, of course, actually be harmed by it. Now, is it because these are not very good drugs, or is it because of a failure to actually target the right medicine in the right dose for the right people? And here's the importance of biomarkers, where if you can identify a class of people who actually do sort of respond well, then what seems to be a very mediocre medicine for a lot of people becomes a great product for those people who are given it, who will mostly respond very well to it. I mean, there's a good example of this, a drug called Iressa, which is for a form of lung cancer. And the response rate of this was like 10% or something. So 1 out of 10 people actually benefited from this drug. Now, it turns out that it was found out that some women, non-smokers, I think it was, and some Asian people, quote unquote Asian, what does that mean? Does it mean Indians? Does it mean Japanese? Does it mean, what about people who live in Jordan? Is that Asia or Middle East? That's not quite good enough. But they did notice that certain people did seem to respond well. Well, that's not really good enough. That's not a good finding in itself, but it is a clue. So they found out that there is a certain gene mutation where that version of the gene is, if you have that, then you are more likely to actually benefit from the drug. So they're able to, basically, while shrinking the patient group, they did end up with a much better, much higher value drug. Now, another way to take advantage of an old medicine is to, which is sometimes done. It sounds a bit cynical, but sometimes these things are done because the pursuit of profit does encourage behavior that may not necessarily be that admirable. But it's just sometimes possible to find a sort of molecular tweak, like a slight variation, where that variation may provide some benefit, which could be substantial, it could be rather unremarkable. But when you identified that variation and done some tests, and you found something about it that gives it some additional sort of usefulness, you can maybe able to get a patent on that, and then you can mark it as a very different thing. So, for example, if I'm allowed to name names here, so AstraZeneca had this product called Losec, and they were making lots of money out of this. As it got to the end of its life, they decided to explore the possibility of separating the mixture of which it is, because it's one of these mixtures where you have half the molecule is a mirror image of the other one. It's so called enantiomers. So they found out that with the left or the right hand, well, I'm not sure which one, but one of them is the one that has therapeutic effect. The other one is not harmful, it just doesn't really do anything. So they came up with this patented drug, a trademark drug, which is called Nexium. Nexium doesn't sound like Losec, obviously. So Nexium, so 5 milligrams of Nexium is really the same as 10 milligrams of Losec. And that's pretty much the only difference. But they market it as a completely different thing. So sometimes you can market an old thing as a new thing by a slight variation. Now, I don't want to be too cynical, because sometimes a separation of enantiomers can actually come up with something that's generally beneficial, that would make a difference. But this wasn't really one of those examples. Okay, so in a way, that's I called that sort of renewing the old, or making the old sort of new, at least for the purposes of marketing. Okay, so that's a few things there. So I've talked about how how to make making money from things that you already have, and that's incredibly important.
Are we getting the kind of invention that we would like to see from providing this tool for companies?
So, well, there are two. There's, of course, the half glass full perspective, and then there's the half glass empty perspective. So the half glass full, the positive, the optimistic view is that actually there are more approvals nowadays than there have been, say, a few years ago. There's been much written about the sort of crisis over the last recent decades, where we don't seem to be as productive as we were. Maybe it's because we've already harvested the low-hanging fruit, and it's unavoidably harder. And maybe that's not something to be too critical in the industry. It's just getting harder because all the easy stuff has been done. The more negative view, the half-glass empty view, is to say that we have these neglected diseases. There are diseases which don't get investment, either because they're difficult, tough nuts to crack, but more often it's because they tend to be ones that afflict poorer people in developing countries. And the incentives, patents do not provide the incentives, drive or motivation to invest or sink research into these areas. There are, of course, complex diseases. And undeniably, I mean, the range of cancer treatments nowadays is amazing compared to what was available a few years ago. I mean, after the First World War, they were treating people with mustard gas as an early cancer treatment, and of course, it did kill the bad cells, but it is also extremely damaging for the rest of the human body. Also, chronic pain. We still haven't really known this one. Obviously, these painkillers that are going around can be highly addictive, and so there must be a better way to deal with chronic pain. People of my age, you start to worry about this, and we all know people who do have chronic pain, and we feel helpless because the treatment is inadequate. I don't think there's even an argument that we need to do much better with chronic pain. Of course, antibiotics, the big antibiotic problem, and which in a sense, I suppose, is a sort of a problem caused by the success of antibiotics. they've been so successful that they've been overused, and now these are losing their effectiveness, and we need, a new wave of follow-on antibiotics, and those are not really coming yet. So we do, I think, need more global innovation. We need innovation to be happening not just in a small number of countries, where those countries understandably have their own particular health profiles of their populations, and which are the target of the research. So we do need to globalize innovation. It is sort of happening, but it could happen much, much faster. Of course, it is expensive to do this research. It is expensive, and countries don't have the money. I mean, I went to Ghana a few years ago, and there are some small companies which have very good people, with PhDs from top universities in North America and Europe, and they had the motivation, but they just need $1 million. We need $1 million so that we can get our first products pre-qualified with the World Health Organization, so that they can then be procured, and that will set them off. So they can't get their first million in order to sort of advance further, which is quite frustrating. And they also need more technology transfer as well. And intellectual property, does it encourage or discourage technology transfer? Well, it can do both. But I think in terms of pharmaceuticals, I think the industry can and should do a lot better than it is in terms of technology transfer. And I think we've seen that with the COVID situation. We can't have another pandemic where the whole world is dependent on a small number of companies in a small number of countries. I don't think we could allow this to happen again, because if we did, it would shame us all, really, frankly.
And what do you think about some of the calls for abandoning or lifting some of the patents rules for example, the COVID vaccine, as were discussed during the pandemic?
Well, I've been actually a supporter of this waiver, because I think that countries do have a sovereign right to regulate IP rights as they think is in their interest. That doesn't mean they'll do the right thing, but I think they should have the freedom to respond to these things in a way they think can work for them. I would have to say that in some ways we are a bit hypocritical. Some years ago in Geneva, I heard an EU diplomat say, and this was during the HIV/AIDS crisis, and I heard him say this. I don't know who he was, and so I can't give him names, but he said, I heard him say that if we had 30% of our population in Europe was HIV positive, nobody would be discussing patents. So
that's a good point. Yeah,
we wouldn't accept patents. We would be quite ruthless about this. Yeah. And we would do what we have to do for our people. So,
are there any other trends that are really shaking this patent system as we have today?
Are there any trends that are shaking the patent system? I think the patent system is doing quite well. I don't think it needs too much support, to be honest. But I think, though, there is quite a lot of discussion about new incentive models. And I think that's a good thing, that's something to be encouraged. I think we need to have a menu of incentive models. And I don't think we should rely on any one incentive model. I mean, we can have an incentive model for new antibiotics that might be different from incentive models to encourage treatments for chronic pain, and other incentive models to encourage investment in complex diseases, Alzheimer's, other cancers that are not treatable or very treatable yet, Parkinson's disease, and these kind of tricky ones. In motor neuron disease, I mean, it scares me that we don't have a cure for this. So So it's different incentive structures. Then there needs to be more of a menu. Right? Now, I know that the FDA and the European Medicines Agency both have think about this a lot in terms of and they do have some kind of rules that might accelerate the approvals for certain kinds of treatment. But is that really enough? Probably not. So, I mean, there has been some discussion about whether we should come up with an incentive model where the industry would be fairly rewarded for what they bring to the public, the true value of that product, in the ways, using the methodologies that health economists employ. But that would not lead to monopoly prices. So in other words, you would get rewarded, you get your money back plus more for your research and development risk and the costs, but it wouldn't be through the price. So, and I think for some diseases that might be a really good way to go, but we need to have more discussion about it, about the practicalities. But I think we shouldn't be afraid to have these conversations.
That's a really interesting idea that we may have to differentiate depending on the disease area, because the incentives will vary. Yeah. Yes.
I mean, sometimes I think it might be that, it's a general debate about intellectual property, is that sometimes maybe it underprotects, in other areas it overprotects.
Yeah, so just like the medicines need to become more precise for the populations, we need to get more specific in the tools we use to
a brand new first-in-class product that benefits a lot of people. You think you deserve a pretty good reward for that. Let's say for an added indication, that's good. But I'm not sure if the right way is necessarily for you to have another 20-year monopoly. Maybe there's another way. Yes, well done. That's very good, right? Could give you 5 years of exclusivity, or some other means of giving you your due for your contribution to society. But I'm skeptical that you should get the same amount of legal monopoly as a company that comes up with a brand new thing that has never been seen before, and it benefits patients in a way that's never been done before. Something that's really groundbreaking. I can think one should try and be a little more flexible about other possibilities. And I know that even some very, very sort of pro-IP lawyers are pretty keen to have this kind of conversation and want to actually think, well, let's see what else might be better. We've had a patent system in my own country for actually next year, it will be 400 years.
Wow.
And of course, it's changed, developed, evolved over those 4 centuries. But is it enough? In other words, should we actually supplement patents with other kinds of incentive? And is a patent system itself due for some kind of rethink and some reform as well?
Well, that leads very nicely into the one question we always ask our guests on the show, and that is if you had a magic wand that you could wave and change one thing in the pharmaceutical industry, what would that be?
I do think, and this is not something that they'll do it by themselves, but I do think the pharmaceutical industry has made itself very unpopular when it aggressively seeks to maximize shareholder value. So I think the shareholder value maximization form of capitalism is something that I'm not sure if we can afford to have this anymore. I think the social responsibility of companies, an industry it couldn't do what it does without having state-granted legal monopolies. And it couldn't do what it does without a lot of research done in universities,
in government biomedical research labs like the National Institute of Health in the United States, and we have others in Europe, of course, who don't always get the credit they deserve for what they contribute. And I do think, for example, Pfizer with the vaccines, I think they've been incredibly aggressive in terms of monetizing the vaccines. They didn't really invent the vaccines. They had these very generous contracts, which helped to mitigate the risk that they would otherwise have to take. So they have managed to actually privatize all of the benefits. But we have socialized, in a sense, all of the fundamentals without which they could never have actually made their money out of this product. Great product, but that aggressive pursuit of shareholder value for me is in this particular case, it's not always, but this particular case, I find it quite immorally concerning, let's say.
Absolutely. Well, Graham, I've really enjoyed our conversation, and I'm sure our listeners will too. If people would like to reach out and have some follow-up questions, where can they reach out to?
It sounds arrogant, but I guess Google me is
makes sense.
Is the easiest way, rather than give you my email address, which is easy to forget once you've heard it.
Awesome. Well, thank you so much.
Okay, pleasure. You're very welcome.
You're listening to Transformation in Trials. If you have a suggestion for a guest for our show, reach out to Sam Parnell or Ivana Rosendahl on LinkedIn. You can find more episodes on Apple Podcasts, Spotify, Google Podcasts, or in any other player. Remember to subscribe and get the episodes hot off the editor.